Imagine you're on a roller coaster of life, but have you ever wondered what would happen if time became the ultimate thrill ride? If it could zoom ahead, hit the brakes to slow down, or even rewind like a cool superpower. Newton thought that time was fixed on a one-way track, moving forward with no stops. But let's challenge his theory. What if our clock wasn't always ticking at the same pace? Buckle up, because we're about to blast off into the fascinating world where Einstein's mind-bending ideas come alive. You've just witnessed a high-speed chase through space, but now it's time to take your getaway on steroids. A super-fast rocket is zooming past, and you spot one last seat. Grabbing this ride will change everything. It's your chance to put Einstein's groundbreaking theory of relativity into action. Time's running out, literally. As you make your desperate dash for that rocket seat, you can't help but think about time and those pesky cops. Just as you jump aboard, you glance at your watch wall, and this is when the wild ride gets even crazier. You're now zooming through space at a mind-boggling 99.999% of light speed. But here's the jaw-dropping part: time on your wristwatch starts moving slower. It's as if time itself has hit the brakes. Get ready for a mind-bending twist. When time feels like it's stretching out like super sticky jelly, does it really have to slow down or stop? Buckle up and let's blast back in time to when Albert Einstein was taking his daily tram ride in the early 1900s. As he gazed at the street clock, a light bulb moment struck. What if the tram could zoom towards the speed of light? According to him, from that point on, his perception would be that the clock outside would grind to a halt. This totally wild idea was the spark that led Einstein to create one of physics' coolest concepts: everything in our universe is relative. Let's dive into some seriously cool physics. Imagine Einstein's neighbor accidentally dropping her specs on a speeding tram. To her, they'd drop straight down. But if someone on the sidewalk watched, oh man, those glasses would be flying along a crazy curved path, all thanks to the moving tram. This mind-blowing difference between perspectives is exactly what led Einstein to shake up our understanding of reality with his groundbreaking everything is relative idea. But here's an even wilder part. Just because you're not on that speeding tram doesn't mean you're completely still. Guess what? You're moving too. Our bodies are always in motion, whether we feel it or not. Get ready to have your mind blown. Einstein's theory isn't just about objects moving. It's also about how we move through time itself. If you sit for 1 minute, you'll be in the future compared to where you started, and that's some crazy stuff right there. Now, imagine being stuck in this exact moment forever. Yeah, no thanks. It's like being trapped in an endless loop of now-ness. But here's the amazing part: when you take a step forward, you're not just moving through space, you're also still moving forward in time. It's like you're always on that never-ending journey into the future. And isn't that wild? Hold on tight, because things are about to get really fascinating. So, when you start moving around, your pace in time gets a teensy bit slower, while your speed through space picks up a notch. It's like you're running on two different tracks at the same time. Think of it like this: imagine you have two buckets that are connected, and whatever you take from one bucket will magically appear in the other. Now, apply that idea to how we experience time and space when we move. It turns out, as your speed increases, it can actually mess with what's happening around you. It's called time dilation, and trust me, it'll blow your mind. Picture this: you're on a platform, and two super bright lightning bolts strike the ground, one on each side of you. Since you're smack in the middle, both flashes hit your eyes at the exact same moment. But now imagine being on a high-speed train, cruising along so fast that it's almost like time is playing tricks on us. From this moving train, things start to look different. The lightning bolt closer to the train will strike first. No surprise there. But here's where it gets really weird. The second lightning bolt will hit what looks like a few seconds later, because time actually slows down for you on that fast-moving train. It's mind-bending, isn't it? Let's keep pushing the boundaries. If we could somehow zoom up to nearly the speed of light, just think of it as a cosmic time machine. We'd travel through time at an incredible pace. Now, I know what you're thinking. We're far from achieving such speeds. And you're right, even our fastest human-made object has only reached a blistering 39,897 kilometers per hour, which is just 3/1000ths of the speed of light. But for now, let's take that leap and imagine we've made it to nearly light speed. Our rocket is getting closer and closer to this mind-boggling velocity oasis. As we push our rocket closer to light speed, I'm keeping an eye on my watch, but it's not ticking like it should. Meanwhile, the pilot gives a thumbs up and the engines roar back to life. The stars outside start streaking by in a mesmerizing red glow due to our rapid acceleration. But let me ask you this, have you ever noticed how time seems to, well, not quite stop, but definitely slow down when things get crazy? That's exactly what's happening here. My watch is frozen like a sticky blob of jelly. Whoa, maybe we shouldn't have tried to break the speed barrier after all. Let's talk about what happens when you start pushing your spacecraft to extreme speeds, like seriously extreme. At just 10% of light speed, things get trippy. Objects start gaining mass and time starts moving slower. Think about it, if we were cruising at 90% of light speed, our spaceship would nearly double in mass. That's a lot heavier, and trust me, you don't want that when you're trying to steer through space. And here's the mind-blowing part, 20 minutes would feel like just 10 on board. But as awesome as this sounds, it gets even wilder when you try to reach light speed itself. Well, your spacecraft's mass becomes almost endless, and guess what that means? It needs an infinite amount of energy, something our most powerful rockets simply can't deliver. So for now, let's just enjoy the view from 10% light speed and appreciate the time dilation effects without actually reaching that magic number. Now let's face reality. In theory, it's just not possible to blast past the speed of light. But imagine we somehow got our hands on that magic infinite energy and decided to give it a shot. As you look out through the porthole at an unfathomable speed, something strange starts to happen. Those distant stars we were used to seeing. Poof, they're gone. The space around us transforms into a dark, eerie tunnel because our eyes can no longer catch those light waves that are racing away from us faster than ever before. It's like the universe is literally closing in, and you'd be left staring into nothingness. You're hurtling through space at an insane 270,000 kilometers per second. That's 9/10 the speed of light. As your ship zooms along, everything around you gets weird. The red lights in the cockpit start to blur and break apart into crazy reflections. Time itself seems to freeze up. Your clock is stuck, completely stopped. You're starting to think this whole thing must be some wild dream. But then, bam, a hail of bullets tears through your ship's hull, a harsh reminder that you're very much awake, and something just got real. Time's running out, we've got a pause on our tail. There's only one way to shake them off, we're going all in on light speed. As we blast past 270,000 kilometers per second, everything around us gets stuck in slow motion. Those bullets freeze mid-air like they're straight out of the Matrix. But here's the thing, these aren't just any bullets. Think about it, when you hit light speed, even tiny space debris like specks from hydrogen atoms or micrometeorites turn into deadly projectiles, capable of tearing through our ship's defenses. And as we're dodging this cosmic hail, somehow we've pushed past the laws of physics and broken free of the light speed barrier, a feat that defies scientific logic. But hey, we've got cutting-edge tech at our disposal, so let's dive into what happens when we go beyond impossible. Blowing past light speed, reality starts warping in some wild ways, cause and effect go haywire, and events start unraveling in reverse. Imagine being able to catch up with photons that were beamed out into space minutes, hours, even years ago. It's like rewinding the universe. Picture this, an old man slowly morphs back into a middle-aged person, then a young boy, and finally a tiny tot, all before your eyes. Time turns upside down as we zoom through the past, leaving the present behind. Mind-bending stuff, causes become effects, and effects turn into causes. Remember, nothing can outpace light, not even our brain's speed of 250 km per hour. If we blast past that barrier, we'd essentially be rewinding to the moment our rocket journey took off. Before you know it, you're back on solid ground, already knowing how your adventure will wrap up. Talk about a time travel twist. The countdown begins again. This time around, we've got a second chance, and maybe, just maybe, you won't make the same moves. Instead of hitting light speed, why not pull off an